Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous few lectures we have been discussing Numpy, and in the previous lecture specifically we were discussing the assignment of values and arrays. So, let us quickly discuss this small part. Array 3D that we had used in the previous lecture. So, if we want to assign array 3D, if we take this array 3D 0, that means the first element in the first dimension, and we are assigning this value 55. So, all the elements that are part of this first element in the first dimension, they are going to be assigned this scalar value. So, you can see in the output number 88 also the same thing is there. You can see the first element in the first dimension, which is a list of lists. So, that has been changed to all those 6 values, first list 3 values, then second list 3 values, and this list of lists those have been changed to 55. So, this is how the value assignment will take place in a multidimensional array. So, few more things are there. Array 3D underscore 0 that we had recorded previously, you can see the values and compare how those values have changed. Similarly, array assignment. So, on the right hand side now you see we have a 1D array np dot array 66 66 66. So, this is a 1D array which is being assigned to an element in the array 3D. Now, what is that element in array 3D? So, you can see 0 indicating that first element in the first dimension, then comma 1 indicating that second element in the second dimension. So, that element which happens to be, if I scroll back, if you see in the output 88. So, first list is 55 55 55, then the second one is 55 55 55. So, first dimension these together are the first element, and second dimension the second of these two is the second element. So, that is going to be changed with these values 66 66 66. So, this is how you can have a look at it. Now, here if I add another code here, and if I look at the value array 3D here. So, let me type this. So, once this assignment take place, so let us perform this assignment array 3D. So, you can see, so whatever the values were there, but you can see this element, this particular list has been changed because of this assignment, which is clearly visible here. So, this is how this array assignment can change elements in a multidimensional array. So, let us move forward. We can always we had recorded this 3D underscore 0 before. We can restore it. We can have a look at the values, first element restored now. Let us move forward. So, like we talked about that these dimensions of these array 3D 0 and array 3D 1, which we can understand now very clearly that these are 2 dimensional arrays. Dimensions of these two would be consisting of 2 1 dimensional arrays. So, if I run this array 3D 1 0 and array 3D 1 1, you can see these are 1D arrays. Now, let us talk about slicing aspects of multidimensional arrays. So, let us take the example of array 2D here. So, if I run this array 2D, so you can see these are the elements. This is a 2D array list of lists, and 1 2 3, then 4 5 6, then 7 8 9. So, if I take just one slice here array 2D and within brackets colon 2. So, what it means is that if I run this, you can see the output 1 2 3 4 5 6. So, 2 is the stopping point, it will not be included. So, therefore, first 2 elements 0 and 1 they are going to be included in the output. So, that is what the output number 107 has first 2 elements there. Now, another if I look at the dimension of this this slicing. So, again array 2D within brackets colon 2, and if I look at the n.ndim object here. So, you can see clearly this is a 2D array. Now, sometimes we might require multiple slicing. So, how that can be performed? So, first thing we need to understand that the first index that will have in the multiple slicing, that will indicate the slicing along the first dimension. The second index that will have while performing multiple slices, that will indicate the slicing along the second dimension. So, if you see the example in 101 array 2D colon 2, that is along the first dimension, then comma 1 colon, that is along the second dimension. So, in the along the first dimension we have mentioned the stopping point, and along the second dimension we have mentioned the starting point. So, if I run this, you can see the output 2 comma 3 you can see here, and then 5 comma 6. So, you can see that in this 0 and 1 along the first dimension, 0 and 1, these two lists have been taken. So, that is 1 2 3 and 4 5 6. Then second slicing is where it starts with 1, that means second element onwards. So, second and third. So, that means two lists that we had selected after first slicing, that is 1 2 3 4 5 6. Now, first one is first one is left out. So, we are left with 2 3 and 5 6. So, you can see how these multiple slicing is working out here. Now, one of these slicings could be paired slicing. So, you can see in the next example array 2D, in the first slicing is paired slicing, and the second one is where we have mentioned colon 1, that is the stopping point. So, if I run this, so first paired slicing means that in the first dimension we are taking all of them, that means all three list elements, and the second slicing is about that the stopping point is 1, that means just the first element is to be taken. So, that is why you see just 1 and then 4 and then 7 in that fashion. So, this is how multiple slicing can be performed. Now, slice expression could also be used for assignment purposes. So, in the next example what we are doing is array 2D, and we have performed multiple slicing colon 2 comma 1 colon, and whatever slicing happens, whatever elements are part of this slicing output, they are going to be assigned this value 0, which is in the right hand side. Another way to understand slicing is that you can consider it like if you have 3D array, you can consider it like a cube, and you are just slicing out some of the parts of that cube, and the output is going to be the remaining part. So, that kind of operation in a sense we are performing when we do this kind of multiple slicing. So, let us coming back to this assignment. So, after performing this multiple slicing, the output, the sliced output, all the elements in that sliced output, they are going to be assigned this value 0, that is there on the right hand side. So, if I run this and I look at the values array 2D, so you can see those 4 elements that we had sliced, those are now the value is 0 0 0 0, that you can see in the output 1 1 2. Array 3D, if let us look at the values again. Now, this three dimensional array, this particular example also we can take to perform slicing. So, let us start with the single slice, one slice. So, just colon 1, right. So, just the first element here, so 1 2 3 4 5 6 in the first dimension. So, this is what we get. Now, multiple slicing, so first dimension and second dimension. So, in the first dimension the first element, and in the second dimension also in the first element. So, as an output we will just get 1 2 3, the very first list in the array 3D. Now, let us move forward. Now, if we look at the you can see the all these outputs that you can see which are related to array 3D, starting from 113, 114 and 115. You can see in all these outputs we have triple brackets there. That triple brackets is always indicating that all these outputs are actually 3D arrays themselves. So, the same thing we can check using the endim object. So, 108 array 3D, we are performing multiple slicing here, colon 1 comma colon 1, and we are checking dot endim here, and you can say 3. So, slicing any 3 dimensional array, the output will also be a 3 dimensional array itself. Let us move forward. Now let us perform triple slicing here. First slicing along the first dimension colon 1, second slicing along the second dimension colon 1, third slicing along the third dimension colon 1. So if I run this, you can see in the output it is a 3-dimensional array with just one value, one element, one scalar value there. What happened here in this case, first slicing colon 1, that means just the first element, that means just the first list of lists. Then the second slicing is also in the along the second dimension, just first element, that means within the first list of list, first list. Then the third slicing is colon 1, that means just the first element, which happens to be the first scalar value within the nested list. So that means just one value is going to be there in the sliced output, so that you can see. Now we can also check the dot endim object for this output also, though it is having just the one element, this is still 3D, so 3-dimensional. So if I run the end dot endim here, then still I will get this output 3 here. You can also check the shape object here again. So if I run this out 111, line number 111, and you can see the output 119. You can see this shape output, this tuple 1 comma 1 comma 1. So as you can see, first dimension only one element, second dimension only one element, third dimension only one element, because there was in total just one element there. So shape output is reflecting that. However, number of elements in this tuple are 3, so it remains a 3-dimensional array. Now can we perform fourth slicing? We do not have a fourth dimension in array 3D, it was a three-dimensional array, but can be performed. So if we try to perform fourth slicing, let us say array 3D colon 1, then colon 1, then colon 1, and then fourth one as well colon 1. So if I run this, I will get an error here. You can see in the error output, you can see no fourth dimension, no slicing. So that is the output that we have got. Now if I perform a slicing where, as you can understand, the stopping point is not included, so therefore if I say colon 0, that means nothing is being selected, so the output will also reflect that. So in line 113, if I run this, it will become line 121 now. So you can see in the output 121, it's nil there, so you can see that. Now let us talk about another aspect related to indexing particularly. So here we will talk about using booleans as index values in arrays, rather or in other words we can say using boolean arrays for indexing. So let us take an example. So what we will do, we will create a random normally distributed data in a 2D format. So we are calling array 2D1, and in the right hand side we are calling this function random.random, and we are specifying the dimensions here. So it is a 2-dimensional, so just 2 values for those 2 dimension, and first dimension having 5 elements, second dimension having 3 elements. So if I run this, I will get in the output 122, you can see the values here. So randomly and normally distributed values in this 5 cross 3 2D array. Once we have created this array for demonstration, let us take at the let us look at the shape object. So it says 5 3. Now let us create a Boolean array. So we are getting a Boolean array with called terms, and on the right hand side we are calling this function np.array, and the list that we are passing is comprising of these string values alpha, beta, gamma, alpha, sigma. So you can see that alpha is coming twice here. We will use this to demonstrate this Boolean arrays indexing. Now if you look at the shape of this terms array, so you can see 1D array consisting of string values, 5 elements. Now what is the example that we want to execute? We want to select indices for the first dimension of array 2D1 which correspond with alpha element values in terms. So alpha you can see there comprising 5 values there, 5 string values, alpha is coming twice. So wherever alpha is coming and corresponding to those indices in the first dimension of array 2D1, we would like to select them. So, for this to happen, number of element in terms and number of elements in the first dimension of array 2D1, they should be equal, which is already the case here. So, we had planned it that way. So, 5 cross 3 is the dimension. So, 5 elements they are there in the first dimension in this array 2D, and we have 5 values also in the terms, this 1D array. So, if I say terms is equal to alpha, then if I run this, you can see I am getting the output in the output number 125 as true, false, false, true, false. So, 2 truths we can clearly see here because those were alphas. Now, I can pass this Boolean expression here in the brackets within brackets for array 2D1 for indexing purpose. So, 119 array 2D1, and you can see terms equal to alpha. So, this will return an output just like in the output 125, and those are going to be used as indices, and those then that is going to be depicted in the output. So, if I run this, you can see the array that we have got. So, you can see corresponding to alpha, the values have been selected here. You can compare this with the output of this array 2D. So, you can see first and fourth element. So, if you can see first and fourth element, only those have been selected. So, you can compare the value, the last 3 digit 507 and 9557 in the output number 126, and here you can see 507 and 957 you can see there. So, those have been selected here clearly. Now, along with this Boolean indexing, we can also combine this with the slicing. So, in the next example what we are taking here is array 2D1. So, you can see terms equal to alpha in the first for the first dimension, and in the second dimension we are slicing 2 column. So, you can see here if I run this, and if you compare the output number 127 with 126. So, you can see when we say 2 columns, so starting from the second, so essentially that means the last last column there. So, those 2 values are there in the output number 127. In addition to what Boolean indexing that we did, we can also pick a particular element in the second dimension. So, in this example you can see next example array 2D1 terms equal to alpha, and then just the index to select a particular value. So, that index is 1 in this case, that means second element in the second dimension. So, if I run this, you can see output number 128, and you can compare this with the output number 126. So, you can see clearly there the second element in the second column has been picked from there. Let us move forward. Now, there might be situation where we would like to select everything except a given value. So, for that also we might have Boolean expression like this, terms not equal to alpha. So, these kind of expression will give this output. Let us run this. So, we will get output something like 129 where false true, true, false true. So, except the indices except alpha, we would like to have everything else in the output. So, if I pass this on for the indexing in array 2D1, so this is what we will get here. So, except those two rows, we have got all remaining 3. So, this is another way, this is another scenario that can be covered using Boolean expression. Now, another tilde operator can also be used to invert a conditional statement. So, sometimes this might also be useful. This is also alternative to what we just did in output number 130 where we used not equal to. So, tilde operator inverting this equal to output, and if I run this, and you can see output number 131 and output number 130, if you compare they both are same. So, this is another way to achieve the same thing. However, tilde operator itself can be really useful in terms of inverting a particular output. Now, there might be situation where we would like to combine certain conditions returning booleans. So, let us understand that also. So, let us take this terms equal to alpha or terms equal to sigma. So, we can combine these two conditional statements here, and if I run this, we will get a returned we will have this array as the returned output, true false false true true, and we can pass this on in our 2D array, and that can be used to select certain indices. So, array 2D1, and this combining multiple condition, this Boolean expression, we can pass it on in the brackets operator, and you can see the output number 133. So, those those rows have been selected here. Now, let us look at the value array 2D1, and another thing that we can perform is sometimes we would like to check whether we like to find out the values in a particular 2D array which are less than 0. So, that is there in 128. So, if I run this array 2D1 less than 0. So, in this Boolean array that we have got in the output number 135, clearly it will indicate which are the values which are less than 0. So, now this can really be used as indices to select indices. So, you can see in the next line of code, array 2D1 within brackets we have this array 2D1 less than 0, and if I run this, only the only the elements which are less than 0, they have been selected here in the output. Now, this kind of thing can also facilitate assignment. So, sometimes first would like to identify the values which are less than 0, and then maybe we would like to transform them to 0. So, that can also be facilitated in one go. So, you can see in the next example, array 2D1, and within brackets we have array 2D1 less than 0, and on the right hand side we have 0. So, this can be easily performed here. So, if I run array 2D1 here, you can see in the output number 138, you can see we have got this matrix here, and you can see many values which were earlier less than 0, now they have been changed to 0, they have been modified. So, this is another useful scenario that can be useful in analytics. Now, let us take another example. So, in this one we are looking to identify terms which are not equal to beta, and then in one go we are assigning the value 2 to all those indices. So, let us run this and let us look at the values. So, you can see in the output number 144 there are many values, many elements which were not beta, and all of them have been changed, and now they carry the value of 2. So, this is another way to use Boolean expression, select indices and also combine it with other kind of slicing and also assignment as well. So, could be really useful in certain scenarios. Now, let us talk about another aspect of this indexing. Now, in this we are going to use integer list or arrays for indexing. So, let us create another 2D array to demonstrate this. So, let us create this array 2D2. Now, in this we are using the empty function. Let us run this, and these are the values in this empty function. You can see in this empty function actually the previous array that we have, that has been assigned to this. Now, we can assign integer values using loop. So, we can run a loop, because this if you look at this 2D array that we have just created, this is a 5 cross 3. So, for each row we can just use a scalar value, integer value, and therefore, we can modify the values of array 2D2. So, if I run this loop and let us have a look at the output, you can see first row is all zeros, then second row all ones, then all twos, then all threes, and then all fours. So, this is how we can modify. Now, the important thing that we wanted to discuss, Now for indexing, we can select elements, that means 1D arrays here from the first dimension of array 2D2 using a list of integer values as indices. So, you can see in this I am passing on a list having 4 comma 2 comma 0. So, this particular list is going to be used as indices here, and that will give us the output. So, let us run this. So, now if you compare the output number 145 with output number 144, you can see that the first list of integer value that we had passed on, first value there is 4. So, that essentially means fifth element in array 2D2, as you can see in output number 144, all 4s. So, that is now coming first. Then the second value in the list was 2, and you look at the output 144, which essentially means third element, all 2s. So, that is the second element in the output from 145. Similarly for 0, all zeros. So, you can see in a sense using these list of integer values, we have done a reordering of those elements in that array 2D2 list. So, a kind of reordering. So, we have still got a 2D array here, and but the reordering of those rows have happened here. So, this is how these list of integer values can really be useful. Now instead of list of integer values, we can also use an integer array as an index. So, in the next example what we have array 2D2. Now, you can see within brackets I am passing an integer array for indexing. So, you can see np dot array, and within brackets again same thing 420. So, you can see the output is going to be same. So, whether we pass a list of integer values or whether we pass an integer array for indexing, both are going to give us same kind of output. Now, let us talk about the negative indices when we are using this list of integer values. So, you can see the output will change. Now, instead of 420, we are passing -4 -2 So, if I run this here in output number 147, you can see now the counting is from the end. So, if you compare this from the output number 144, so you can see that if you do the counting from the end, first ones will come, then for -2 the 3's will come, and for zeros it is there. So, in this fashion it will happen. Another example where we are going to use some list of list for indicing. So, before that let us create this another 2D array. So, here we are using another method, reshape method. So, this is typically, this particular reshape method is typically used to fix dimension. So, here if you see this what I have in this line of code array 2D3, and on right hand side I am using a range function. So, value is 32. So, the values would be from 0 to 31. So, I am going to create a value an array with values 0 from 0 to 31 and with 8 cross 4 dimensions. So, dot reshape method that allows us to pass on that dimension, the desired dimension that we want. So, if I run this and let us look at this output 149, you can see we have got an 8 cross 4 array. This is a 2D array, and the values are from 0 to 31. So, in this fashion we this is another way to create an array or reshape. Now, let us talk about the next aspect, which is using multiple list of indices. So, till now we talked about the list of indices with just one listing that we had used. It is also possible to use multiple list for indexing, which is also referred as fancy indexing. So, in this case it is important that number of index values that are there in the list, in both the lists, they should be equal, and first list is for first dimension and the second list is for second dimension. So, the operation, the way this operation takes place, it is very similar to specifying a cell in Excel. So, array 2D3, and you can see we have within the brackets we are passing two lists here, one consisting of values 1 3 5 which are going to be indices, and then second is 0 comma 2 comma 3. If I run this, it is something like this, like along the first dimension we have taken the second element, the index value is 1, that means second element, and in the second dimension we have taken the index value 0, that means first element. So that means that that elements happens to be 4. Then similarly the next matching, so in a sense matching is happening here. The next one will become corresponding to 3 and 2, so it will be 14, and the next one will become 23. So a matching kind of thing has happened here. This is called fancy indexing. Multiple lists are being used here. Similarly, we can take another example here. Array 2d3, we just pass one list of values that for indexing purpose. So 1 3 5, you can see that second row and fourth row and sixth row they have been selected. Now we can also use it in another example where we are doing the multiple indexing. So first one is 135, that means the output number 151 we can refer to. Then in the second one, second brackets, we have multiple lists there. So one is bare slicing in a sense, the second one is list of integers. So again a matching will happen there. So for along the first dimension we are taking all the elements. In the second dimension we are having 0 2 comma 3. So if I run this, we will get this kind of output. So this is another way to actually perform this multiple listing. So we would like to stop at this point, and in the next lecture we will start our discussion on transpose of an array. So let us stop here. Thank you.